Good evening. I hope you are well. Today we are going to talk about integration. Integration is the process of reversing the derived function. Do you understand? So, when I say integration is the reverse, is the process of reversing the derivative of any function, not a certain, but any function. Understand? So what does that thing tells you or forces you? That thing forces you to have a deep understanding of what? A deep understanding of the derivatives. So for you, for you to know integration, you must know how to differentiate, because you are going to differentiate in this concept, and also you are going to integrate. Do you understand? So let's say you have a certain function f of x. Understand? That's a certain function f of x. So with that function f of x, if you derive this function, you move from f of x to f prime of x. For you, meaning from here to here, what did you do? You derived. Understand? You derived. This is what you did. So whenever you want to know, let's say this function, you don't know this function, but then they tell you that this function is derived from f of x. So you want to know what was here, what was that function. So this integration concept is going to tell you or what was there. So in other words, the integral of f prime of x with respect to what? To x. Remember, with derivatives, like let's say we were deriving a certain function, we say d over dx. Let's say we're deriving x squared. So we were seeing that we are deriving with respect to something. How? We are seeing this dx was guiding us. It was telling us that we are doing what? We are deriving with respect to x. Meaning you are going to derive where you see what? You are going to derive with respect to x actual. Understand? So that thing was telling you that you are deriving with respect to x. Ne? Even with integration, the dx, it will tell you what are you doing. Or actually the d, it will tell you that what are you deriving or integrating. So when you had a d over dy, this thing tells you that you are doing what? You are deriving with respect to y, meaning you must derive what? You must derive y. Understand? So the derivative of this thing is what? Is 3y squared. Understand? That's how that concept works. Ne? But then yeah, I think you get me. So here it tells us that this dx, it tells us this function, it deals with x's. They derived with respect to x. Hence, in this function, they say f prime of x. Understand? So, the integral of f prime of x, remember the integral is the reverse of what? Of the derivative. Meaning the answer of your answer here is going to be what? Is going to be f of x plus c. Understand? Because you moved from where? You moved from f of x. You did what? You derived. Now you are going backward, which is anti-derivative. You are anti-deriving. Understand? Hence you get that answer. So meaning that the integral of f of x dx is what? Is bigger f. Is bigger f of x. Understand? Then you say plus c. So I think now you are asking yourself why I say plus c. Understand? Let me show you why I say plus c. That c is very much important in this concept of integration. Let me tell you why I say c. Before I tell you why I say c, I say plus c, let me show you another concept. Let's say you are deriving a certain function multiplied by a constant. Do you remember this concept? So you remember we were allowed to do what? we were allowed to put that c we just let that c be, then what, then derive the function just like that. Understand? Meaning that this thing is talking about something like this. Let's say you have 3x squared, meaning you are doing what? You are going to leave the 3 as it is, ne? Then you deal with whatever they told you must derive. They told you must derive with respect to x, meaning you are going to deal with this x squared only. So when you derive that thing, you get what? You get 2x. Therefore, you simplify, you get that 2 times 3 is 6. You get 6x. That's how that thing works. Even integration, if you are integrating a certain function multiplied by a constant dx, you are allowed to put that constant outside of the integral. Then you remain with what? With f of x dx. Remember, multiplication is cumulative. What does that thing mean? It means multiplication, it does not matter. Let's say you have 3 times 2. Multiplication is cumulative. 3 times 2, you can rewrite as what? As 2 times 3. It does not matter. It's still a same thing. Ne? Even addition is cumulative. Let's say 3 plus 2. Doesn't matter if you write it as in like 2 plus 3. But at the end of the day, you'll get what? You'll get 5. You'll get 5. Here you'll get what? You'll get 6. You'll get 6. But then if you look at those things, they are what? They are not in order. But then it's cumulative. Ne? But then addition, subtraction and division is not cumulative. Ne? Meaning that if I have negative 2 plus 3, ne? If I say, let's say I subtract something from something, ne? I cannot say minus 3, or I say this thing is the same as 3 minus 2. No, it's not right, because here the answer is what? The answer is negative 1. Then here the answer is 1, meaning that subtraction is not cumulative. Even division, if I say, let's say I say 6 divided by 3, this thing is not the same as 3 divided by 6, ne? Because here the answer is 2, and here the answer is 1 over 2. This one is not cumulative. Then addition and multiplication, they are cumulative. I think you get the point by now. So let's go and check another concept. Let's say we have different functions, ne? So we're trying to integrate certain function. We're trying to integrate f of x. We're trying to integrate g of x. Understand? So what are you going to do here? You are going to just multiply each and every function. Like you integrate function by function. Meaning you are going to integrate f of x multiplied by dx, plus you integrate g of x multiplied by dx. If you can check, we multiply this side by f of x, and then we multiply by what? By g of x, and then we also multiply by the integral sign and also the what? The dx. Understand? Because this thing is like this. Let's say we have 2 into x plus y multiplied by 3. Understand? So the thing that you can do, you can multiply this 2. You can have what? You can have 6, then you have x plus y. Then when you multiply them together, you get 6x and what? Plus 6y. Or you can just multiply them like this. This one comes here, this one comes here, and then this one, it comes here, and this one comes here. Step by step, meaning you are going to have what? You are going to have something like 2x multiplied by 3 plus 2y multiplied by 3. Eventually you will get what? 6x plus 6y. Do you see how we came here? Is because we take this thing here and took this one. If we wanted from the beginning, we were gonna take this one and multiply by this one, then take that thing as a whole, multiply them in the bracket. Understand? I think now you are getting the point. Even if in subtraction, let's say they want you to integrate f of x minus g of x, dx. You are going to remain with something like what? The integral of f of x dx minus the integral of g of x dx. That's how that thing it was gonna work, ne? So let me quickly check if this thing is recording. Yes, it is recording. Then now, meaning that in addition and subtraction we treat them the same, ne? Meaning the integral of f of x plus or minus g of x dx is the same as what? The integral of f of x dx plus or minus the integral of g of x dx. It does not matter. If it's positive, it's positive here. If it's negative, it is negative even here and here. Understandable. I think now you are used to the procedure. Ne? Sometimes we just manipulate some sort of functions. It's very important to know. Do you remember those trick functions? Like how to work with trigonometry. They say simplify this. Let's say they gave you something like 2 sine x cos x divide by something like let's say they gave you something like, what can they give you? They give you something like okay, let me do it like this. This is sine 2x cos 2x divide by what? By cos 2x. You must also have that thing from high school of knowing how to solve this thing. You know, in this concept, you were gonna change what? You were gonna change the cos there in the denominator. Actually, you don't have to change the cos in the denominator because the cos already they cancel each other. You must also have that concept even here, and also how to manipulate some certain function. Let's say they give you a cos 4, let's say a cos 4x minus a cos sine 4 to the x divide by what? Divide by a cos 2x. Understand? And they say simplify this thing completely. You must know that deep concept from high school. You must know this thing is the same as what? Is the same as cos squared x all squared minus sine squared x all squared. And then when you change the cos, you check the denominator, okay, is cos and sine, meaning you can change it to what? To cos squared x minus sine squared x. Ne? So when you change that thing, you know this thing is the difference between two squares. It's the same as a squared minus b squared, which is the same as what? As a minus b, then a plus b. So you must have that concept, meaning here you have what? You have something like what? You have something like a cos squared x minus sine squared x. Then you have a cos squared x plus what? Sine squared x. Divide by what? Divide by a cos squared x minus sine squared x. You know these two, they cancel. You remain with cos squared x plus sine squared x, which is equal to 1. You must know also how to do those things because you are going to be exposed to many things. Understand? So let's try to talk about how to work with this thing. Ne? Let's say we have a certain function f of x. They say that function is 2x squared plus 3x minus 7. Understand? So let's try to derive the thing. I want to show you why are we saying the integral of f prime of x equal to, with respect to x, equal to f of x plus c. We're saying that c is a constant. Let me show you how are we doing plus c. Ne? So when we derive that function, we get that function is 4x plus 3. Understand? Because the derivative of any constant is a 0. Understand? Meaning that if we try to go back, we remember, we say, okay, there was a constant there. But then there are many numbers. There are infinite real numbers. You cannot just assume we had this unless they give you a condition. Understand? So here now, we are trying to go back to this function. We are trying to go back to this function. Let's try to go back to that function, meaning that we are going to try to integrate this function and see if we will get this function. Ne? So let's talk about a formula first. Ne? Remember the formula of deriving with respect to x, of x to any number n. Ne? We were doing what? We were dropping the n, then subtract the what? Subtract the 1 from the exponent. Ne? So with integral, we are doing the inverse. Ne? So meaning the integral of x to the n dx, we are doing what? Remember, we're starting by this one. We did what? We subtracted 1, meaning that what is the inverse of subtraction is addition. If we don't subtract, we add. Ne? So we're going to say n plus 1. So let's come here. Here we have what? We have multiplication. What is the inverse of multiplication? The inverse of multiplication is division. Let me show you how. So let's say we have 2 times 5. Ne? So 2 times 5 equal to what? Equal to 10. Ne? So if I want to remove that n, that 2, I'm going to divide it by what? By 2. So that such that I cancel, I divide by 2. I cancel, I remain with 5. Ne? So if you want to cancel something that is being multiplied, you do what? You divide by it. Ne? But then if you want to cancel something that is being divided, let's say 5 over 3, 6 over 3. If you want to cancel something that is being divided, you multiply by it, because the inverse of division is what? Is multiplication. Therefore, they cancel. Ne? Something like that. So now we're going to divide by what? By n plus 1. Then we say plus c. Understand? So now let's go to our function. We had the function f of x equal to x squared plus 3x minus 7. Then when we derive that function, we get what? We get 2x plus 3x plus 3 actual plus 3. Understand? So now let's try to move from here to here. We're going to do what? To integrate. We know we want the integral of 2x plus 3 with respect to x. We know we're going to do what? We're going to treat them step by step. Remember, we have a constant there, 2. We leave it like that. We deal with the x. We have a 1 here. So the formula of integrating, it says what? N plus 1. So we're going to do what? We know the formula of that one. It says n plus 1 divided by n plus 1. So we're going to add 1 here. And then divide by what? Divide by 1 plus 1. Then we say plus. We come to 3. Remember, always, all the time, we have x to the 0 is equal to 1. Is equals to 1. Ne? Is equals to 1. Meaning where there is any constant, let's say 3, 7, negative 4, we also have what? X to the 0, x to the 0, because it's the same as what? As 3 times 1. Ne? 7 times 1. Meaning here we're going to do what? Also we're going to add 1. Then we do what? We divide by 0 plus 1. Then we say plus c. You will see why I say plus c. So what is 1 plus 1 is 2. 2 divided by 2 is what? Is 1. So which means we remain with x squared plus 0 plus 1 is 1. 3 divided by 1 is what? Is 3. We have 3. 0 plus 1 is what? Is 1. Meaning we have x to the 1 plus c. We see that thing is what? Is our f of x. Understand? Remember, our f prime of x was what? This was our f prime of x. We integrated it, then we got what? We got x squared. Here is x squared. Then 3x, here is 3x. Then plus c. Then our c is what? Is a number. It's not always can be -7. The reason why, because the derivative of any constant is a 0. Meaning the derivative of -10 is a 0. So we cannot assume what was there, because it can be different types of numbers that were there. Since where any constant is a 0, meaning the derivative, when we get 0, it's not easy to go back and assume what was there. Is it gettable? Because they won't give you the function, they won't show you the function, they won't give you this one, they will only give you this thing and say to you, integrate it. Do you see? Then that's how we introduce the concept of what? The concept of integration. Even here, let's try and check. Let's say we have f of x, x to the n. Then when you derive that thing, we get what? We get n, we drop the n, then we subtract 1. Ne? So let's try to integrate this thing and see if we will get what? Remember, here we can have what? We can have 0. We can have -9, -10. Understand? Even the derivative of 0 is 0. Ne? So let's try to integrate this thing. Let's try to integrate n, x to the n minus 1 dx. First step, we do what? We keep that constant, is a number. Ne? Then we are going to that exponent, we are going to do what? We are going to add 1. You say plus 1. Then divide by that thing, which is n minus 1 plus 1. Then we say plus c. So meaning we're going to have n. Then remember, these ones, they cancel, so you remain with n. Divide by this one, they also cancel, you remain with n. These n's, they cancel, then you say plus c. Meaning your answer is what? Is x to the n plus c. That's your f of x. That's how integration works. Understand? It takes us from the derivative to the original function. Understand? Yeah, that's how we talk about integration. In the next video, we will be integrating the functions now.